Morning to all of you. You are present in Dr. SR Chemistry Lecture Series. A new lecture series I am starting today, and that is a lecture series on chemical bonding. Lecture series on chemical bonding. Today I will give you only the introduction of chemical and electrovalent or ionic bond. So today's lecture topic will be your introduction of chemical and electrovalent bond. Now, before starting this topic, there are certain points or there are certain important things which we should know. And first of all, this term, first term is your valency. Valency you have already studied in your previous classes. It represents the combining capacity of an atom of the element. So this valency is combining capacity of an atom of the element. Now, since we have started the topic of chemical bond, so we should know what is meant by chemical bond or what is a chemical bond. What is chemical bond? The bond is formed in between two or more atoms. And certainly there are some forces which are holding the atoms together in the molecule. And therefore, the force, which will be definitely the force of attraction, the force of attraction holding the two or more atoms in a molecule is called as chemical bond or simply bond. So chemical bond, it is a kind of force of attraction holding the atoms together in the molecule. Now the question arises that what is the need for the formation of chemical bond by the atoms of the element, or what is the need of the valency? In order to know this, we should take help the theory given by Postel and Lewis. He proposed that each and every atom tends to gain stability, and stability will be gained, or a system will be more stable when it has minimum energy. And if you look on the periodic table, we find that in the periodic table, the most stable are the least reactive elements are noble gases, and these are helium, neon, argon, krypton, xenon, and radon. They are the most stable are the least reactive elements of the periodic table. He observed the electronic configuration of these elements and found that in each of these elements except helium, which has 2 electrons in its outermost shell, are in the valence shell. Each of these elements have got 8 electrons in its outermost shell, and the electrons present in the outermost shell is called as the valence shell. So in short, we can say that the noble gases or stable element are least reactive because of the presence of 8 electrons in their valence shell, except helium, which has got 2 electrons in its valence shell. So he attributed that the atom tends to gain stability, and stability will be gained when it will have 8 electrons, or more precisely we can say that when it will have outer electronic configuration of its nearest inert gas, or the valence electronic configuration of its inert gas. So this theory was proposed by Russell and Davis. It is also known as electronic theory of valency. Electronic theory of valency. And according to Russell and Davis, atoms tend to gain stability or have minimum energy and in order to achieve it, they enter into chemical combination into formation of chemical bond. Formation of chemical bond or chemical combination so that they could acquire outer electronic configuration of its nearest inert gas. Outer electronic configuration, as I have told you, for that I mean the electrons present in the outermost shell are in the valence shell. Now the noble gases are helium, neon, argon, krypton, xenon, and radon. Helium, neon, argon, krypton, xenon, and radon. Radon is a radioactive element, but because of its similarity in the electronic configuration with the noble gases, it has been placed along with these elements. These are noble gases. Previously, these were called as inert gases because these were thought to be completely inert. But now it has been found that under certain conditions, some of the elements have tendency to form chemical compound. That's why these have been termed as noble gases in an analogy with the noble metals, platinum, silver, gold, which also have very tendency to combine. Now, if you see the electronic configuration, helium 1s2 has two valence electrons. So the nearest inert gas of hydrogen is helium. That's why hydrogen will tend to acquire the outer electronic configuration of the nearest inert gas. And in this way, the number of electrons contributed by an atom in the formation of the chemical bond, that will be termed as its valency. So hydrogen needs one electron. I will show it by the Lewis dot structure also. Needs one electron to get electronic configuration, nearest inert gas electronic configuration. That's why valency of hydrogen is 1. Likewise, neon has got electronic configuration 1s2, 2s2, 2p6, valence electron 8. Argon, this has 1s2, 2s2, 2p6, 3s2, 3p6. This also has got valence electron 8. And likewise, krypton 36. This has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6. So out of these 8 valence electrons, 2 are present in S and 6 are present in P. Therefore, we can also say that elements tends to acquire S2P6 electronic configuration of its nearest inert gas, and that's why they show valency, or they enter into chemical combination, or they have tendency to form chemical bond. Except hydrogen, which has electronic configuration 1s1 and its nearest inert gas is helium, so it tends to acquire the 1s2 electronic configuration of its nearest inert gas, that is of helium. Now, before studying that different type of chemical bonds or different type of chemical combination or the different ways in which the atoms can combine to form the chemical bond, we should know that how to write the Lewis dot structure of the elements or the atoms of the element, and how is it helpful in finding the valency of the element. So writing of Lewis dot structure of atoms of element. For writing the Lewis dot structure of the elements, first we write the symbol of the element. As for example, lithium. Its symbol is lithium. And the valence electrons present in this element is represented with the help of dot or cross. And valence electron can be known from the electronic configuration. Lithium has electronic configuration 1s2, 2s1, valence shell is the second shell, and therefore the number of valence electron is 1. So the Lewis dot symbol of lithium is Li with 1 dot. Similarly, if it is magnesium, magnesium has electronic configuration 1s2, 2s2, 2p6, 3s2. Valence electron 2. Therefore, magnesium can be represented like this. by Lewis-Dot structure. Oxygen 1s2, 2s2, 2p6, 2p4, valence electron 6. Therefore, Lewis-Dot structure of oxygen will be like this: 6 electrons. These 6 dots present the valence electrons present in the electronic configuration of the element. Likewise, chlorine 1s2, 2s2, 2p6, 3s2, 3p5. Valence electron 7. Therefore, chlorine can be represented like this: 4, 6, 7. 7 dots are representing the 7 electrons, which are also the valence electron of these atoms in its electronic configuration. Now, what is the importance of this Lewis-Dot structure or Lewis symbol of the element? On the basis of this Lewis symbol, we can find the valency of the element, and also we can find that how many electrons this atom can contribute in the formation of chemical bond. So, importance of Lewis-Dot structure. Importance of Lewis-Dot structure. Of atoms of element. The number of dots around the symbol of the element this is equal to valence electron, means the electrons present in the outermost shell. And if valence electron is equal to 1, 2, 3, and 4, then valence electron is equal to valency of element. For example, carbon has valency 4, because valence electron is equal to 4. Likewise, if you see the magnesium has valency 2, because valence electron is equal to 2. Now, if the number of valence electrons are 5, 6, 7, or 8, then valency is equal to 8 minus valence electron. If valence electron is equal to 8, then valency is equal to 8 minus valence electron. For example, oxygen valence electron 6, so valency is equal to 8 minus 6 is equal to 2. Likewise, chlorine valence electron 7, therefore valency is equal to 8 minus 7 is equal to 1. And likewise, nitrogen is not represented here, Nitrogen has valence electrons 5. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3, 2s2, 2p3. Valence electron 5. That's why 5 dots are there. So in case of nitrogen, valence electron is equal to 5. Therefore, valence is equal to 8 minus 5 is equal to 3. On the basis of valency and on the basis of valence electron or the Lewis dot symbol, we can find that how many electrons this atom of the element can contribute in the formation of chemical bond. So valency of the element also represents the number of electrons contributed by that atom in the formation of chemical bond. So the valency is equal to number of electrons contributed by that atom in the formation of chemical bond. So if the valence is 2, as for example in case of oxygen, it means it will contribute 2 electrons in the formation of chemical bond, whether it is electrovalent or covalent bond, that I will tell you right now. Similarly, if the valency of nitrogen is 3, it means it will be contributing 3 electrons in the formation of chemical bond. Or its 3 valence electron will be utilized in the formation of chemical bond. Similarly, in case of lithium, the valence electron is 1. That's why it will contribute its 1 valence electron in the formation of chemical bond. Now, what are the different ways in which the atoms can combine to form the chemical bond, or what are the different kinds of chemical bond? Different ways of formation of chemical bond. There are 2 different ways of the formation of chemical bond, either by the transfer and gain of electron in between the atoms, or by the sharing of electron in between the atoms. So you can say that there can be 2 different types of chemical bonds. The one bond is formed by the transfer and gain of electron in between the atoms. And this results in the formation of electrovalent bond, which is also known as ionic bond. The other way is by the sharing of electron. Between the atoms. And this sharing of electron can be in 2 different ways. Either the shared paired electron is equally contributed by the two atoms, or it is contributed by only by one atom. That's why this results in the formation of two different types of bonds. Equal number of electrons are contributed by atoms in sharing process. This results in the formation of covalent bond. And if the pair of electrons required for the formation of chemical bond is contributed by only one atom, then this results in the formation of coordinate bond. Pair of electron required for formation of bond is contributed by only one atom. This will result in the formation of coordinate bond. So basically there are two types of chemical bonds. One is electrovalent bond and the covalent bond. The covalent bond can be formed in two different ways, either by the equal contribution of the electrons by the two atoms, that is, this bond is simply known as covalent bond, and if the contribution of the pair of electrons required in the bond formation is contributed by only one atom, then that type of covalent bond is called as coordinate bond. Now let us come on electrovalent or ionic bond. Electrovalent or ionic bond. This type of a bond is formed by the transfer and gain of electron in between the atoms. Formed by transfer and gain of electron between atoms. And which atom will transfer electron? That which is electropositive in nature. Which atom gains electron? That which is electronegative in nature. So you can say that the bond is formed in between highly electropositive and highly electronegative elements, or formed between highly electropositive and highly electronegative element. And in periodic table, the most electropositive elements are the highly electropositive elements are the elements of first hand group, And the highly electronegative elements are the elements of 17 group, that is halogens. And also oxygen and sulfur and nitrogen. Oxygen and sulfur belong to 16 group, while nitrogen belongs to 15 group. So that is when alkali or alkaline earth metals alkane metal in first group and alkaline earth metals belong to second group. Combined with highly electronegative elements, highly electronegative elements, that is halogens of 17 group or oxygen, sulfur, 16 group. So this electrovalent bond is formed when the alkali or alkaline earth metals combine with high electronegative elements like halogens, which are present in 17 group of the periodic table, and oxygen and sulfur are 16 group. But lithium, alkali metal, and beryllium, alkaline earth metal, these do not form electrovalent bond, which I will tell you in detail in my next lecture for the conditions for the formation of electrovalent bond. But in short, here we can say that if the electronegative difference between the metal and non-metal is either 2 or greater than 2, then only the formation of electrovalent bond or ionic bond is possible. So in case of lithium and beryllium on combination with halogen or oxygen and sulfur, we find that the electronegative difference is less than 2. That's why they are not able to form the electrovalent bond or ionic bond, but they form covalent bond. Now let us see that how does the formation of electrovalent or ionic bond is taking place. And I have told you that this type of bond is formed by the transfer and gain of electron, and the atom which is transferring electron will be electropositive in nature. That is, it will have tendency to give the electron, and the atom which is gaining electron will have tendency to accept the electron. So the atom which is giving electron tends to exchange into its corresponding positive ion, and the atom which is gaining electron is changed into corresponding negative ion. And these positively and negatively charged ions are held together by an electrostatic force of attraction, which is known as electrovalent or ionic bond. So, as for example, it is sodium chloride. Sodium belongs to first group, chlorine belongs to 17th group. That's why it is natural that if this will be an electrovalent bond, this is in first group, and this is in 17th group. In order to show the formation of the electrovalent bond, you first write the electronic configuration and find their valence electron: 1s2, 2s2, 2p6, 3s2, 2s2, 2p6, 3s1. Its valence electron is 1. Chlorine 17, 1s2, 2s2, 2p6, 3s2, 3p5. And I already told you that elements tend to gain stability, and stability is gained when they have outer electronic configuration of their nearest inert gas, that is S2p6, or in case of hydrogen, it tends to acquire one S2 electronic configuration. So here, if sodium loses one electron, it will gain S2p6 electronic configuration, and if chlorine accepts one electron, it will gain the stable inert gas configuration. So this is your sodium containing valence electron 1, represented by Lewis dot structure. Chlorine it will transfer its one electron, so there will be formation of Na plus and Cl minus ion, which are held together by electrostatic force of attraction, and that's why this bond will be called as electrovalent or ionic bond, and this compound will be called as electrovalent or ionic compound. Now, I have told you earlier that this is also helpful in knowing the valency of the element. The number of electrons contributed by an atom in forming the chemical bond, that is termed as its valency. So, since sodium is transferring one electron, that's why its electrovalency will be 1. Chlorine is accepting one electron, that's why its electrovalency will be 1. Consider another compound, calcium oxide. This calcium has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Valence electron 2. Oxygen, this had valence electron 1s2, 2s2, 2p4, valence electron. So, if oxygen accepts 2 electron, valence electron 6. If oxygen accepts 2 electron, it will acquire stable electronic configuration, and if calcium loses 2 electron, it will acquire stable inert gas configuration as 2p6. So this is your calcium atom, 2 electrons, oxygen 6 electrons. These 2 electrons are transferred. Since 2 electrons are transferred by the calcium atom, that's why it will acquire 2 positive charges, and oxygen atom will acquire 2 negative charges, changing into oxide ion. Now, number of electrons transferred or gained by one atom of the element, that is termed as its electrovalency. So here the electrovalency of calcium will be 2, and that of oxygen will be 2. So this is all about my today's lecture, and in my next lecture in this chemical bonding series, we shall take more examples of electrovalent and ionic bond, and also the factors affecting the electrovalent bond, that will include the lattice energy also, a new term. So this is all about today. Thank you.